This video is going to talk about the transformation called reflection and how it relates to our trig functions sine and cosine. First of all, let's talk about what is a reflection. In nature, we see reflections all the time. You look in the mirror in the morning, that's a reflection. Here we see two swans reflected in a lake. We have the original swans and their reflection. You can also see reflections in other bodies of water, like puddles or the ocean sometimes, and in other kinds of metals, particularly shiny ones. But in math, we have a little bit more of a precise definition of a reflection. On the right over here, you see a coordinate grid. On the top, there is a triangle that I'm outlining right now, and it has been reflected over the x-axis. In math, we almost always talk about a place over which it was reflected. Specifically, this video is going to deal with reflections over the x-axis. So for example, this point C started at 4, 2, reflecting it over the x-axis to C prime, put it at 4, -2. Basically, whatever distance a point is above the x-axis, we simply bring it below the x-axis. Our swans over here actually make a really nice parallel for the math definition. You can see that this right swan's beak is perfectly reflected below into the water. Same with the left swan's beak reflected down here. Let's now see what this means for sine and cosine. Here on the left is a graph of sine. If we want to reflect this over the x-axis or over the midline, we will simply take all points that are above and put them the same distance below the x-axis. So these maximums come down here to become minimums. And then all points that are below the x-axis have to go above the same distance that they were below. So just to track one point, if we look at point A as this maximum, this point comes down to become A prime below the x-axis as a minimum. So if I connect these new dots, you'll see I have something that looks very similar to the original curve, just kind of twisted around. The graph over here on the right shows both curves graphed together, with the blue curve, the reflection, and the light red, the original parent function. Notice, while the parent function, if you start at the origin, it goes up to a max, down to a min, back to the midline. The reflection starts off going down, then goes back up, and then back to the midline. That's really going to be our distinctive feature. The reflection goes down from the midline on sine. You may now be wondering what the equation for a reflection looks like. The equation for a reflection has a negative sign in front of the amplitude. So for example, if our original is y equals sine of x, the reflection would be y equals negative sine of x. This works pretty much the same way with graphs of cosine as well. On the top left, you'll see a graph of the parent function y equals cosine of x. When we change this equation to y equals the negative cosine of x, we do the same thing as we did with sine, where we take all of the points above the x-axis and bring them below the x-axis. So you'll see that right here. So this maximum that was right on the y-axis has become a minimum still on the y-axis. So rather than going in the original, cosine went max to max, in our reflection, or in y equals negative cosine of x, we're actually going to go minimum to minimum. And down here on the left, you can see both of them graphed together, with the red representing our original y equals cosine of x, and the blue showing our reflection of y equals negative cosine of x. Here I made a summary table of what one period of sine and cosine look like for positive in front of the amplitude or negative in front of the amplitude. It's worth noting that these functions never have negative amplitudes. The amplitude is always a positive number. In the equation, it may say -3 sine or -2 sine. The amplitude is still a +2, even though it would show up as negative in the equation. The negative is really just telling us if we have a reflection of the original or not. So looking just at sine, you can see if we have this blue line as our y-axis and then that white as our midline, when it's a positive in front of the amplitude, we start our period of sine going up, back to the midline, and then back to the down and back to the midline. Whereas if it's a negative in front of the amplitude, we start at the midline, go down first, then go up, then go back to the midline. With cosine, we'll start our period at a max, go down to a min, and back to a max if we have a positive in front of the amplitude. And we will start at a min, go up to the max, then back down to the minimum when we have a negative. So they're really just doing the opposite as what they were doing before, which is really what a negative sign means, just do the opposite. Let's see if you can try graphing one. My recommendation here is to graph this or set up your points as if there was no negative sign here. And then when you go to connect the points, you know, you'll have your 3 dots like you usually do with sine. When you go to connect the points, rather than going up, down, and back, you will go down, then back up, then back to the midline. So like this blue one here, not like the green. So why don't you give it a try? Pause the video. On the next slide, I'm going to show you the answer. I'll start graphing this just like I started all my other graphs by putting in the midline, which I know is +2. So I still have my dashed midline at +2. Then I'm going to put in my amplitude, which is still a +2. Even though there's that negative sign there, the amplitude's still positive. So I go up 2 to +4, and that's my maximum. And then I'll go down 2 to 0, and that will be my minimum. Last thing to do is find the period. We know by now that the period is 2 pi divided by b. My b here is 2, so my period is 2 pi divided by 2. My 2's cancel out, so my period's just pi. So now I hadn't labeled my axis, but let me do this. So pi, 3 pi over 2, and 2 pi. Great. So I know my period, first period, will end right there at pi. So now I'm pretty much all set. Sine is midline, midline, midline. And now is when I need to remember that this is a -2 sine 2x plus 2. So when I start here at my y-axis, I'm going to go down to my take that back. There we go. So I'm going to go down to my minimum, back to my midline, up to my maximum, and back to the midline. And that is not a beautiful graph. Hopefully yours was prettier. The important thing is that you did not go up first. That is not what you want to do because of that negative sign. And as always, I could always add in another period here. So to sum up, if you see a negative sign in front of the amplitude of a sine or a cosine equation, that just means reflect the entire graph over the midline. Thanks for watching.